Hello and welcome to another on-demand training for B3. Today we're going to be looking at the Site and Water updates that are coming with version 3.2 revision 3. My name is Matt Tierney. I'm an architect by training and a professional research fellow at the Center for Sustainable Building Research, which is CSBR. So this is an introduction to the incremental changes in the guidelines, specifically in the Site and Water sections of the forthcoming revision. We have put these revisions out for public comment and hope to solicit feedback by September. At that time there will be a couple of weeks of review, and then we will issue the new revision. These changes are geared towards three primary goals. The first is making the requirements and intent of the guidelines more clear. The second is making it easier for project teams to report and calculate values for various site and water sections. And the third is making caveats or exceptions to certain guidelines to account for the real world project constraints and conditions we've been finding on many projects. So we'll talk through the specific changes that were made to the Site and Water sections, the B3, during this on-demand training, but please feel free to follow up if there are additional questions or concerns related to your team's specific project. Let's get started. For those not very familiar with the Site and Water guidelines, there are 5 primary sections: site and water connections, site water quality and efficiency, soils, vegetation, and animal habitat support. We're going to go through these overarching categories to try and align the intent of what the guideline was written to try and encourage and projects developed within the state of Minnesota. And then go through each of those different sections and show you what's changed in them to try and make the guidelines more aligned to the real world conditions that we've been finding in so many projects. The first section is Site and Water Connections, S1. The main intent of this section is to create sites that are resilient, healthy, and sustainable, and to ensure the connections between the surrounding environment and the site are preserved through vegetation selection, provision of animal habitats, and connections to human-made systems. You'll see that we underline and bold some of the words in each of these sections to highlight where the revisions are targeted for this update. We want project teams to contextualize their project within a larger ecosystem and watershed boundary in this section. This sort of larger systems approach allows project teams to better connect habitat and other hydrologic cycles to a larger context. S2, Site Water Quality and Efficiency. The main intent of this guideline, or set of guidelines, is to restore the natural water cycle of Minnesota biomes and to support efficient natural and constructed hydrologies, healthy soils, robust vegetation, and ecosystem services. Overall, we want to reduce and limit waterbound pollutants leaving the site and optimize potable water use. Lastly, we want to respond to the ecological factors of the project site as part of a larger watershed, which we talked about in guideline S1. S3, Soils. The intent of this guideline is to ensure the maintenance and restoration of healthy soils by documenting existing soil conditions, preserving and protecting benefits of existing soils, minimizing the impacts of construction, repairing soils to return to supportive conditions, and documenting soil maintenance practices to ensure ongoing optimal soil conditions. So on top of not disturbing what is already happening on site, we want to increase biodiversity both above and in the soil. We want to maintain healthy living roots, and we want to maximize the amount of soil cover with vegetation. Natural and ecological processes within the soil take a long time to develop. And so one of the primary intents of the S3 soils section is to not interrupt what's already going and to continue to encourage healthy long-term soil benefits. S4, vegetation. We want to optimize the ecological function of project sites by restoring Minnesota's native vegetation, protecting natural areas, conserving existing site features, and selecting vibrant and appropriate vegetation to ensure the optimum functioning of ecosystems and human uses on the project site. So to the right here, there's a map of level 3 and 4 ecoregions and a county level survey map. And so within the guidelines, we ask that project teams evaluate the location of their project site relative to other natural areas, scientific natural areas, and areas that are part of the MBS survey to determine what the most appropriate habitat type is, but also the most appropriate native vegetation based on more site-specific project conditions that the project team knows best. This is an example of one of the overarching goals of this set of revisions is to empower the project team to be able to use their professional opinion and judgment to make the most appropriate decision instead of the guidelines determining what the actual condition is that would be most suited to the site. S5, animal habitat support. The intent of this guideline is to protect and support site animal habitat resilience by reducing the negative impact of the built environment and construction on animal species and providing supportive environments for at-risk native species that are essential to ecosystem health. For this guideline, we ask that project teams look at a few different resources in order to determine what the best fit is for the project's specific conditions. Looking at the Minnesota DNR's subsection profiles and habitat descriptions is a great way for teams to get a better idea of what pre-settlement vegetation and ecosystems were in the project area. We'll talk more about the resources that we allow teams to use to determine the most appropriate animal habitat to install on their site when we get to that section of the revisions. We think that these principles are well aligned with the intent and guiding principles of the professional community, which is architecture, landscape architecture, civil and mechanical engineering, and environmental engineering. So we hope that the intent of each of these sections that we just ran through are generally agreed upon and important to you all. However, if you have an idea or want to weigh in on how these principles could be better integrated with the variety of projects that happen in Minnesota under the B3 program, let's talk. We're always looking for ways to improve and hone the methods of getting these principles into the real world. If you want to send us an email, emails can be directed to guidelines@b3mn.org. We work with B3 project teams daily to both answer questions and assist in moving projects through the B3 process. We also solicit feedback more broadly on our entire program throughout those calls, as well as in follow-up focus groups. If you are interested in a particular issue or want to be part of a focus group, don't hesitate to reach out to your agency contact or at guidelines@b3mn.org. The changes that are summarized in this short on-demand training are the result of these focus groups and ongoing management of the standards while the building industry and we evolve simultaneously. This is a general overview of the topics that received changes during this revision. They're all shown here in this list, which will serve as a rough outline of this training. A lot of these topics that we're going to cover are the outgrowth of feedback and our own team experience dealing with projects and project constraints at many scales within the B3 program. We hope the changes that I'm going to run through here make it easier to do the things that we all agree are the right thing to do and not needlessly adding complexity to your project workflow or design process. With so many teams experiencing trouble achieving stormwater volume retention goals within the B3 program, the guidelines didn't provide an accurate and readily usable tool to calculate evapotranspiration for land cover that was not accounted for in MIDS within the B3 program. With that in mind, we wanted to renovate the site albedo tool, which was primarily developed to help reduce urban heat island effect and encourage more vegetation on site, to be able to kind of broadly calculate the evapotranspiration contribution of vegetated site areas to the overall volume reductions demands in S2 that are quite hard to hit, especially for sites that have some restriction. As you can see from this diagram, beyond the obvious benefits of having more vegetation on site to promote healthy soils and to reduce urban heat island effect, the benefits to overall stormwater volume management on site can be significantly bolstered if evapotranspiration from vegetated areas is taken into account. Here's where you enter each of the different square footages of the different hardscape and vegetated areas of the project site. Things that are in yellow are for the team to assign, and items in blue are calculated values that self-populate based on the team's inputs. These cells should be left alone and not changed, as they already have formulas embedded in them. So you should start with your total site area and then use the different relative albedo numbers that are in the list embedded in the tool to fill out the chart. Make sure that your overall site percentage is 100 when you think you're done. And to do that, only one material can be used for each separate zone of the site. Areas are either hardscaped or have vegetation, but one zone viewed as a site plan, from above, cannot be used for both. A little bit more detail on this will be provided when we do in-depth training on the ET and albedo calculator. In a non-evapotranspiration focus sense, we've also simplified the amount and complexity of materials that are available to input for hardscape albedo in this tool. So we've simplified the options, simplified the list, and arranged it, really going pretty linearly from low albedo to high albedo. So the team should choose the best material to suit your project's needs, and these values go in the bottom row of the calculator, yellow there, that is set up for an input. So overall, this revision of the evapotranspiration and albedo calculator is really geared to supplement the MIDS calculator, which has been standard for volume and quality measurement within the B3 program for a long time. The issue with MIDS is that not all stormwater BMPs contribute evapotranspiration to the overall volume reduction requirements, and so we found that it's necessary to use MIDS in coordination with the albedo plus ET calculator to get a better estimate of how much ET is actually reducing overall site stormwater volume that's managed on site. In line with the modifications to the stormwater evapotranspiration requirements in the new calculator, we've also updated our guidance on hydrologic soil group determination, so that's HSG for short, and we've done this based on the guidance in the Minnesota Stormwater Manual. It's important to note that a infiltration test is still required of the project team to determine this, but now we've also included guidance on testing methods, including the infiltrometer test and a couple of other methods if the project team chooses. Links to the stormwater manual and other resources are available directly in the guidelines text and also in the meeting the guidelines section. We encourage project teams to try and establish their HSG as early in the process as possible, just given that if you have D or C-type soils, it can be extremely hard to meet the volume reductions that are required for on-site if you have soil condition, whether it's the actual composition of the soil or a constraint to meet that volume demand. One of the most common questions that we get at CSBR when talking with project teams is how do we establish the percentage value of stormwater that needs to be managed on site for project sites that have some sort of restriction against infiltration. Some common causes of this are wellhead protection zones or karst soils, easements, and more. So we've altered the stormwater requirements for these types of sites with infiltration restrictions to be able to use the same volume reductions as a site that has D-type soils. This gives some leeway given that infiltration is generally the easiest and least costly method of reducing overall stormwater leaving the site. It's important to note for this guideline that D-type soils are still required to infiltrate 85% of overall storm water volume arriving at the site. So this exception doesn't obfuscate the team from needing to comply with the rules entirely, but rather it reduces the overall volume that needs to be managed on site and pushes project teams to explore alternative options. Those alternative options are trying to rely on evapotranspiration, which is now part of the site albedo calculator and was partially accounted for in MIDS. That's one of the methods, and the other is to capture and reuse rainwater that's collected from a roof and is one of the EPA approved reuse strategies for roof collected rainwater. We've been trying to promote the use of green roofs as a means of simultaneously addressing energy savings, ecological potential, and also stormwater and habitat function. In order to do this, we wanted to set up a incentivized multiplier that could be used for areas of green roof. Under the new revision of B3, green roofs are incentivized for roof captured rainwater that are for storage and reuse. We hope that a more widespread use of green roofs are encouraged through this incentive, and that more teams pursue these critical parts of a regenerative built environment. Further, we believe that this will have benefits not only to stormwater and habitat, but energy savings and much more. In S2, we've also completely reworked the irrigation and outdoor water calculator. The new calculator hopes to encourage drought-tolerant plantings after the establishment period, and also allows the use of a high-efficiency irrigation system that utilizes captured and reused rain or roof water if the project conditions require alternative means of volume management within the project site, or if the project team elects to use captured rainwater for irrigation. There will be a more in-depth and detailed tutorial on the new irrigation and outdoor water calculator later this fall, but this is available to use and for comment currently. As you can see, we're trying to reduce non-program required turf grass throughout the site, and trying to have low water demand plantings in all of the microclimate zones that are possible. So overall, just trying to reduce the irrigation demand based on those two principles. And then where irrigation is desired, either for program required turf or for irrigation systems that are using harvested rainwater, we want that irrigation system to be as efficient as possible. So there's a number of different guidelines and requirements, kind of specifications for the high efficiency irrigation system that are now included in line within the guidelines. S4, class fact sheets for determining adjacencies for vegetation and for habitat requirements. This is an area that we've received many questions on, both for the process and intent of the B3 guidelines. We've now provided a couple of different options for project teams. So you can either use the class fact sheet or the nearest SNA to determine the most appropriate vegetative species to include on site. Our intent with this change to the guidelines is to more closely relate surrounding ecosystems to those provided on the project site. With that comes the intent of the guideline to reinforce habitat corridors, establish and connect patchwork landscapes and stepping stone habitat types across the state. We believe that giving options to project team members was the best way to allow the professional landscape architecture community to make informed decisions based on the nuances of every different B3 project site. So the big change here is that now there's multiple places to kind of reference and find the most applicable species for both vegetation and habitat type. So in addition to the class fact sheets that we saw on the last page, we're also allowing using scientific natural areas or SNAs, which can be found on the DNR's website, but also, and maybe more importantly, within the DNR's Conservation Explorer tool. This tool is an online GIS-based resource that allows project teams to be able to find adjacencies and kind of locate their project within a larger context. These two options should give project teams, and specifically landscape architects, a clear and direct way to be able to navigate their native plant selections and habitat types that are most applicable to their site conditions. Over the past few years, we've received a number of questions and comments on the process for obtaining various state departmental reports and approvals for habitat types. We previously required the NHIS or Natural Historic Inventory System report along with a plan from the Minnesota DNR if species were found within the required buffer zones. However, that process was not working very smoothly for project teams, and we wanted to make it easier while still kind of going with the intent of this guideline. So we've simplified the habitat determination by using the Conservation Explorer tool. The tool not only lets you locate your project within larger watershed and habitat corridors, but it also allows you to do the Natural Historic Inventory System report directly within the tool in a very, very short amount of time. So there's no longer the need to coordinate with MBS or DNR staff directly to determine the habitat requirements on site or to develop a plan for them. So it's the responsibility of the landscape architect or other project team member that is assigned to this guideline to identify key species that were part of the NHIS report, and then determine which are the best to provide habitat for on site. Lastly, within S5 habitat requirements and habitat determination and documentation, we've updated the habitat requirements for year-round water features to only apply to sites that are larger than 20 acres. We found enough evidence through our work with project teams over the past few years that the value added by having the year-round water feature on small sites was not justified given the energy and maintenance demand in Minnesota's cold winter climate. Therefore, only large sites which may actually provide a significant natural habitat during Minnesota's winter months should have areas that need to be kept open with an aerator, bubbler, or other type of device that prevents full ice over of a water body during Minnesota's winters. So this is a summary overview of the changes to the site and water sections of B3 that are now available for comment until September of 2026. Project teams are able to request early adoption guidance for these tools and guidelines from B3 staff. Midstream teams will be able to adopt this version of the B3 guidelines upon request. And if you have any further questions or comments on these revisions or on the site and water related issues that we discussed in this presentation, please reach out to your agency contact or send an email to guidelines@b3mn.org. Thanks so much for taking the time today to review the site and water changes in the new revision of the Minnesota B3 guidelines.